Okay, this is going to be a short video. This is going to wrapping up fault types, and we talked about hanging wall and footwall. So if you see the fault where the rock's broken there, or probably up there, you can actually imagine going down here. This is the hanging wall, here's the footwall, hanging wall and footwall. And if you take a look at that dark band, it looks like the dark band is slid down, hanging wall moves down. This is done by tension, and this makes what's called a normal fault. And you can actually see the surface was right here. This top part is not faulted, it's not actually brought down. So what happened is the ground level was here and sediment has gone in, filled in the low areas, and actually filled up there and probably was up higher and is now eroding away. Looks like a very dry location, even though it looks kind of wet down here. Normal faults create something called Grabens. Grabens, German form of the word valley, and basically what happens is the hanging wall moves down on this side, hanging wall moves down on this side because we're diverging, we're tensioning this plate boundary, and what happens is the block falls in. There's another example where it goes up, like if there was another normal fault over here, this would be called the hoist, which was not the valley floor, but the section of rock that goes up to actually make the valley sides and the top. And which is the hanging wall, which is the footwall? If you stand right there and you imagine on this fault, this is the one that's above your head, this is the one below your foot. It is normal motion for that ball to go down. This is a normal fault. Oh, there's actually a horse right there. So we've got a graben and a horse. This is Africa. And Africa has what's called the Great Rift Valley, and if you take a look, you can actually see some high areas and low areas in between. This was diverging in years past, volcanism in there. You can see it actually started forming a lake. As this actually gets deeper and deeper, if it were to do that, eventually the salt water from both the Indian and the areas around Arabia up here, Red Sea and Black Sea, the waters would actually go in and we would have an inland sea, and we'd have a broken part of Africa sitting over here and the other part of Africa sitting over on this side. Okay, here's another fault type. All you got to do is find the fault. There's one right there. Find the hanging wall and the footwall. Find rock types on both sides. Looks like the hanging wall has moved up. This, of course, would actually be caused by compression, and this is what's called the reverse of normal. This is a reverse fault. Reverse faults come in two different flavors. If it's a low angle or a high angle, we actually call this a reverse fault. If it's a low angle where one is being sort of thrust on top of the next, this is called a thrust fault. But they're both types of reverse faults. Hanging wall, again, moving up. There's the fault. Wall above your head, wall below your feet. Hanging wall goes up, that's got to be compression, and that is a reverse fault. Same thing here, hanging wall moves up, compression, that's a reverse fault. Then we have what's called the strike slip, and if you take a look at the fence is moving. Looks like this side's moved off to the right and this side's moved off to the left. This is a right lateral fault. If you take a look, this is the San Andreas, probably the most common fault. This is running through California, and it's actually changed the course of rivers, it's changed the course of roads, and it's got a mountainous scar on both sides of this fault line, which would be going from, I think, the northwest down to the southeast, headed towards Baja California. What is this caused by? This is a shearing force, and these are called strike slips or lateral faults. And this one, you can't really tell which direction the fault is, and I can't tell which way the river valleys have gone, but this probably is the section of the fault that's moving up, and this is probably the section moving down, which would make this the North American plate, and this the Pacific plate. Here's a strike slip fault. We've got a cow minding its own business, chewing on grass. We've got a fault that goes across it. It builds up stress. Here goes the earthquake. Knocks over the cow, breaks the fence. If you're standing on this side, this is going off to the left. If you're the cow and you stand back up and take a look at this, this was the left, so this is a left lateral or a left strike slip. It's called strike slip because there really isn't a hanging wall. The fault is straight up and down. Here's a picture of the entire seismic tectonic section of the planet, where we had North America and Africa touching. It's split apart. It's going at 2.5 centimeters per year, and if you take a look at the divergent force, this would be the location of normal faults, and the section falls down and actually fills with the Atlantic Ocean. We go to the Pacific Ocean, where we have the North American plate cruising off this direction at 2.5 centimeters per year. We have this plate moving up from the bottom at faster speeds, and what happens is we've got this plate sort of sliding up this direction, this plate sort of moving down here, and we have this little section of California, Baja California, which is really belonging to the Pacific plate, and the rest of California and the rest of Mexico on the North American plate, and this is slipping up. And if you take a look at it, this is a right lateral fault. California goes this way and to the right from the Pacific, and Pacific slides up, and it's actually headed up toward this trench, this divergent area, two plates colliding. We have lots of divergent, and where you actually get the transform faults, if you notice, these things are offset, where this side of the plate's moving this way at 3.8, this side's moving, and it doesn't give you the speed, but it looks like it's right around 3.8. This plate's moving this way, this plate's moving that way, and because they're moving in opposite directions on two sides, that's the shearing force, and that's what's actually going on. Is North America has moved over this. This is a divergent area that actually slides down, and North America has moved over the top of it, and basically what's going on is that little section between the divergent areas, that's this large section right here, and it's actually moving as a shearing force. So we have divergent, we have convergent all along the Pacific Ocean, making what's called the Ring of Fire, even though there's a whole lot of volcanism when we rip this crust apart. And I'm going to call it quits there. So that's the end of this level, and hope you enjoyed it. We'll talk about seismic waves, body waves next time.